All right, good afternoon. Mr. Trutna here. Happy National Family Pajama Day, November 14th, 2019. We are currently at Clovis High School. We're going to go over Unit 6, Worksheet 2, numbers 1 through 10, and numbers 13 and 14. Okay, as is tradition, here we go. Let's start it off with our joke of the day. So what happened when Benjamin Franklin finally invented electricity? He was shocked. Think about it. There you go. Good. All right, after this video, remember, smash that like button. Give me some money. Okay? All right, here we go. Here is Unit 6, Worksheet 2. What we're doing, the instructions say, determine if the triangles are similar. Complete the statement of similarity. State the postulate or theorem that justifies the similarity. And if not similar, we're just going to write not similar for both A and B, and then we're going to explain why it is. Okay? So, in part B, when it says state the postulate or theorem that justifies the similarity, remember there are three postulates or theorems that justify similarity: the AA postulate, the SAS postulate, and the SSS postulate. Okay, so if we say that the two triangles in the picture are similar, and we're always talking about triangles in this problem, then we're going to use one of these three postulates in part B. Okay, so let's just jump right into it. So number one. First thing is you want to recognize the two triangles that they're talking about. So clearly, number one is comparing this triangle right here, which is the big triangle, which I just outlined in green, and it's being compared to this triangle here, EDC, which is the triangle that I'm outlining in yellow. Okay, so those are the two triangles that I am comparing. And if you notice, there is no information given about any of the sides. There are no numerical values, no numbers on any of the sides of any of the triangles. So that means there is no possible way these triangles could be similar by side angle side or side side side. So that means if they are similar, it has to be similar by angle angle, or it just means they're not similar at all. So angle says the two triangles will be similar if they have two angles that are equal to each other. Okay, and they do. There's one of them right there. Angle C is congruent to itself. Notice how angle C is in the green triangle ABC, and it's also in the yellow triangle DEC. So that's one angle right there. Okay, then the other angle that would be, the other set of angles that would be congruent would be this angle right here, would be congruent to that angle right there, and the reason why those two angles are congruent is because they're corresponding angles. So in part B, we're going to use the angle similarity postulate. Okay, in part A, we're just going to complete the statement of similarity. So triangle A, B, C is similar to triangle, so A would match up with D, so D has to go first. B, which goes second, matches up with E, and then C matches up with itself. So that's number one. Okay, number two, here we go. So number two, I'm not going to outline the two triangles because they're pretty straightforward, the two triangles that you should see. You've got triangle PQR, which is this triangle on the left. It's a little bit smaller than this triangle on the right, which has XZQ in it. Okay, so right away, hopefully you notice that we have vertical angles in the picture. As we've said in class, vertical angles will never be marked as congruent. You are responsible for recognizing vertical angles, and you have to know that vertical angles are congruent. So, notice, I have a pair of angles that are congruent, and then I have numbers on two of the sides of each one of the triangles. So that means, logically, side angle side would be my choice. Okay? Can't be side, side, side because I don't have numbers on three sides. And angle is probably not going to be it because I only have information about one angle. Now, so side angle side. So remember, side angle side works if you have information about two sides in each triangle and information about one of the angles in each triangle, and we have that, and the angles are included between the two sides, and they are. Now, side angle side will only work if the ratios are proportional. So let's write the ratios. 6 would correspond with 8. 9 would correspond with 12. So side angle side would work here if those ratios are proportional. And the way that you tell if you only have two ratios, cross multiply to see if the ratios are proportional. So 9 times 8 is 72. 6 times 12 is 72. They are proportional, so this one would be side angle side similarity. Now we're going to complete the statement of similarity. So P is going to be the same as X. Q, the middle letter, is going to be the same as Q. And then R is going to be corresponding with Z. So triangle PQR is similar triangle XQZ. Okay, number 3. There's your two triangles that we're comparing. Now, what information do we have? Notice we are given information about 3 sides of each one of the two triangles. So that means that if they are similar, the only logical postulate or theorem would be side, side, side. Side, 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 though, only works if all the ratios are equal to each other, okay, or proportional. So let's write the ratios out. I'm going to write the small triangle. When I write the ratios out, I'm going to write the small triangle, and I'm going to compare it to the big triangle. So 5 from the small triangle corresponds with 10 in the big triangle. 4 from the small triangle corresponds with 8 in the big triangle. 7 from the small corresponds with 15. Okay, now these two triangles would be similar if all of these ratios are the same. In other words, if they're all proportional. Now, if you have 3 ratios, to tell if they are all proportional, what I would suggest is you just reduce all 3 of them. Don't cross multiply, it could get a little too complicated. Okay, so 5 over 10 reduces to 1 over 2. 4 over 8 reduces to 1 over 2. 7 over 15, you can't even reduce it. So you can see they're not all equal to each other, so they're not proportional. So that means that these two shapes are not similar. So I'm going to write not similar in A and B, not in A, similar in B. And then we need to explain why are they not similar. Okay, here's the reason. All ratios are not proportional. Okay, so that would be number 3. They're not proportional. Number 4. Okay, so are these two triangles similar? Let's see what information we have. Notice we are given information about 3 sides of triangle ABC, the small triangle. 3 sides of triangle ABC, the big triangle. They're both called ABC. That's kind of weird. Okay, I know, hey, that was the same in number 3. All right, so which of these possibilities makes logical sense side, side, side? Okay, so but remember though, side, side, side only works if all of the ratios are proportional. So I'm going to write out all the ratios. And once again, I'm going to write the small triangle's values in the numerator, the big triangle's values in the denominator. So 6 from the small triangle corresponds with 9. 4 from the small triangle corresponds with 6. 8 corresponds with 12. Okay, so these two triangles would be similar if all of those ratios are in proportion. In other words, if they're all equal. And once again, if you have 3 ratios, the best way I think to check to see if they're all equal is just reduce all 3. 6 over 9 reduces to 2 over 3. 4 over 6, if I divide both numbers by 2, that's how I'm reducing. I'm doing it in my head though, reduces to 2 over 3. 8 over 12, if I divide both numbers by 4, they reduce to 2 over 3. So notice they're all equal, so that means that these two triangles are similar because of the side, side, side similarity rule. Okay, then I'm going to complete the statement. So the triangle ABC is similar to triangle ABC. Okay, that A matches up with that A, that B matches up with that B, that C matches up with that C. Number 5. Okay, number 5 is a little bit tricky because you have to tell, you want to tell which two triangles are we actually comparing, and there's actually 3 triangles in this picture. One of the triangles, and it gives you a hint, PQR. So PQR is this triangle right here, which I'm outlining in green. And then we're comparing it to the triangle right next to it, SQR, which I am outlining in yellow here. Okay. Mellow Yellow. I like that song by Taylor Swift. Shout out. Taylor Swift. Okay, so let's look. That angle is the same as that angle. That's good. That angle's 90. This angle right here has to be 90 as well because those two angles are adjacent on a straight line. That means they have to add up to 180. If one's 90, the other has to be 90. So how many angles are equal to each other in the two triangles? 2. So that means these two triangles are similar because of the AA postulate rule. Okay, now we're going to complete the statement. So triangle PQR, there's P, the first letter, is going to match up with R in the yellow triangle. So R has to go first. I know that by the congruent marks. Q is the second letter in PQR, that's the 90. It's going to match up with Q in the other triangle. And then the other letter would be S. So triangle PQR is similar to triangle RQS. Okay? Number 6. I'm not going to highlight the two triangles because they're obvious. All right? And you should notice right away that this triangle has vertical angles. Okay? And this is number 6, so that means what do we have? Well, we have an angle, and we have 2 sides in each triangle. So this would mean that side, angle, side is my only possibility. Now let's see if it actually works, though. We have to set up the ratios. Okay? So 6 corresponds with 8. 9 corresponds with 12. These two triangles will be similar if those two ratios are in proportion. So let's cross multiply and see. 8 times 9 is 72. 6 times 12 is 72. They are similar. Okay, so triangle PQR, P is the first letter. It would match up with X. Q is the second letter. It would match up with Q. And then R, the third letter, would match up with Z. There we go. That would be number 6. Okay? Number 7 is a word problem. Now, when you're doing these word problems in number 7 and 8 and 9, you want to make sure you draw a picture. So a 6-foot tall man is standing next to a tree. The man's shadow is 4 feet long. At the same time, the shadow of the tree is 10 feet long. How tall is the tree? Whoops, sorry, you can't even see that. There we go. Just take my word for it. What I read is true. You can read it again. There we go. How tall is the tree? Okay, so let's draw a picture. We have a man. He is 6 feet tall. We have a tree that he's standing next to. So I'm going to draw the tree over here. I'm going to make it a pine tree. I like pine trees. It means I'm up in the mountains. Okay, the man's shadow is 4 feet long. Remember, the shadow always has to run across the ground, so that's his shadow right there, 4 feet long. At the same time, the shadow of the tree is 10 feet long, and the shadows are going to go in the same direction, and shadows always run along the ground. Remember that. That's 10 feet long. How tall is the tree? So I'm going to call that H. Okay? So the concept in this problem is you've got a triangle right here. You've got a triangle right here. And those two triangles are similar to each other. Okay? So what we do to solve for the height of the tree is we set up our ratios. So when I set them up, I'm going to do the big triangle. So when I set up my extended ratios, I'm going to write them as big triangle over small triangle. A value from the big triangle is 10. It corresponds with 4 in the small triangle. Another value from the big triangle is h. It corresponds with 6 from the small triangle. And then what we do is we put these equal to each other and we cross multiply in order to solve for h. Okay, so 4 times h is 4h. 10 times 6 is 60. Remember, the 60 is called the means. The 4h is called the extremes, and the means is always equal to the extremes. And then I divide by 4, so I get h is equal to 15 feet. Okay, there's how tall the tree is in number 7. Number 8. There's a typo here. We've got a flagpole, so a 1.4 meter tall child is standing next to a flagpole. The child's shadow is 1.2 meters long. At the same time, excuse me, this is not the typo, it's in the next problem. The shadow of the flagpole is 7.5 meters long. How tall is the flagpole? Okay, so let's draw a picture of this. We have a child who is 1.4 meters long, tall, excuse me, 1.4 meters. M stands for meters, not miles. That'd be crazy if he was miles tall. He's standing next to a flagpole. So here's my flagpole. Okay. The child's shadow is 1.2 meters long. So remember, the shadow always extends from the person along the ground. So that's 1.2 meters long. At the same time, the shadow of the flagpole is 7 meters long. The shadow will run the same direction as the previous shadow. 7.5 meters long. How tall is the flagpole? So h, trying to figure out the height of the flagpole. Once again, you look at this problem as creating triangles. You've got the flagpole, you've got the shadow, and then actually this line right here is the sun. It's the sun's ray that's going down and creating to the end of the shadow from the top of the object. Okay? And then what we do is we're going to write our extended ratios. So for this one, I'm going to write the small triangle's values in the numerator, the big triangle's values in the denominator. So 1.4 from the small triangle corresponds with h in the big triangle. 1.2, the shadow of the small triangle, corresponds with 7.5, the shadow of the big triangle. And I cross multiply in order to solve this problem for the height of the flagpole. So I'm going to multiply these. So h times 1.2 is 1.2h. That's the extremes. It's going to be equal to 1.4 times 7.5. And I'm doing that off screen so you could see this right here, 10.5. Okay. Divide both sides by 1.2, and that's going to give you your value for the height of the flagpole. So 10.5 divided by 1.2. Once again, Michael, I'm doing this off stage. Don't be that impressed. Can't do this in my head. It's 8.75. So h is equal to 8.75. There we go. Number 9. Victoria wants to find the height of the flagpole. Victoria is 5 feet tall. She stands 70 feet away from the tree. That's a typo. I think that's supposed to say flagpole. My mistake. And her shadow is 12 feet long. Find the height of the flagpole. Okay, now this problem, when we draw it, is a little bit different. So we got Victoria standing right here. Fun fact, Victoria is the name of the capital of British Columbia, which is a province in Canada. Okay, but she's 5 feet tall. She stands 70 feet away from the flagpole. So that means over here somewhere and over here is a flagpole. Here's my flagpole. Victoria is standing 70 feet away from that flagpole. So that means this right here is 70 feet. Okay? And her shadow is 12 feet long. Now think about it. Which way would her shadow go? Would her shadow go to the left of her, to the right of her? Okay, I guess it could go either way, because if the sun was up, say, here, it would go that way. But I'm going to pretend the sun's up here. So I'm going to have her shadow go to her right. Okay, I guess really it doesn't matter, but that's going to, oh shucks. The power just went off. Ugh. Oh, that's because I was heating up some steak tartare. Let me turn off the oven. That's me walking. All right, the oven's off. Ah, lights are back on. Awesome. Okay, so now for this problem, you want to think of it in terms of triangles. Here is a triangle, right there. Okay, now the other triangle is a little bit tricky. The other triangle that we're going to compare it to would be this entire thing right here. Like that. Okay, so you've got like a little triangle that's created by Victoria and her shadow and the sun's rays inside the big triangle. Okay, so now so what I'm going to do is I'm going to set up those things called proportions, my extended ratios. I'm always going to take the big triangle's values, put it in the numerator. I'm going to put the small triangle's values in the denominator. Hope that you're okay with that. So let's pick a length, and remember I want to find the height of the flagpole, so that's h. So h is a value from the big triangle. It corresponds with 5. The heights correspond with the little triangle. Then the very bottom of the big triangle, if you notice, it's not 70, it's not 12, it's 70 plus 12, 82. So the bottom of the big triangle is 82, and then the bottom of the little triangle is 12. So these are my extended ratios, and I can't write a third one because I don't know anything about these two sides here. Okay, so I'm going to put those equal, and I'm going to cross multiply to solve. Okay, so I'm going to go h times 12, I'm going to go 5 times 82. H times 12 is 12h. That's the means. It's going to be equal to 5 times 82, which is 410. I divide both sides by 12, and that's going to give me my height of my flagpole. So 410 divided by 12, Kobe, I'm doing this off screen, I'm not doing this in my head, is 34.16 ... So there's my height of the flagpole. All right, number 10, review. The quadrilaterals shown are similar. Okay, so it tells us right away these two shapes are similar to each other. We're going to find the scale factor of the larger quadrilateral to the smaller. Okay, that's very important. So we're always going to write the large quadrilateral as the numerator, the smaller quadrilateral as the denominator, and then we're going to find the values of A, B, and C. Okay? All right, so let's talk about the scale. So first of all, in order to find the scale factor, we're going to write out all the ratios. Okay? Large to small. So 15 from the large quadrilateral corresponds with B. A from the large quadrilateral corresponds with 6. 12 from the large quadrilateral corresponds with 8. 35 from the large quadrilateral corresponds with C. So these right here are all my extended ratios. That's the first thing you want to do. Now to find the scale factor would be these reduced. Okay, well there's only one of these ratios that you could actually reduce, and it's 12 over 8. 12 over 8, if I divide both of these numbers by 4, I get 3 over 2. So that's my scale factor, 3 over 2. Okay, now typically we would have more ratios that we could reduce, but since each of the other ratios have a variable in it, I can't reduce it. Now we're going to use these ratios to find the value of A, then B, then C. Okay? And what we're going to do is, so to find the value of A, we're going to pick the ratio that has A in it, which is A over 6, and then we're going to make it equal to another one of these two ratios. Okay? And you want to pick one that doesn't have a variable in it. So your choice is 12 over 8. So we're going to go A over 6 is equal to 12 over 8. And we cross multiply. 6 times 12 is 72. That's equal to A times 8. That's 8A. You divide both sides by 8. A is equal to 9. Okay? Then I'm going to do the same thing for b. So I'm going to pick the ratio that has b in it, 15 over b. I'm going to make it equal to one of these other ratios, 12 over 8. That's really my only choice I have. Okay? And then I'm going to cross multiply again to solve for b. b times 12 is 12b. 8 times 15 is 120. I'm going to divide both sides by 12, so b is equal to 10. Okay, now we're going to do the same concept for c. So for c, I'm going to pick the ratio that has c in it, which is 35 over c. I'll work it out inside this quadrilateral. Then I'm going to make it equal to one of these other ratios, and I'm going to pick 12 over 8 again. Why do I keep picking 12 over 8? Because it's a ratio that has two numerical values. And I cross multiply. c times 12 is 12c. That's equal to 35 times 8. Doing this one off screen on a calculator, 280. And then I'm going to divide by 12. And so c is going to be equal to 23.3. Dot, 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 dot. Okay, there we go. There's number 10. Okay, we're going to skip number 11 and 12. And I'll just tell you why, because in order to solve these, you would have to know the quadratic formula, and we don't learn that until second semester. So let's go to number 13. Okay, so at number 13, we're going to solve for x. Okay? So how do we solve for x? Remember, the first thing we want to do is we want to write the extended ratios. So I'm going to set them up with the small triangle as the numerator, the big triangle as the denominator, and since I have information about three sides, I'm going to be able to write three of these. So that means 9 from the small triangle corresponds with 12. Another ratio would be 18, and 18 would correspond with 4x minus 4. And then the third ratio would be 21 corresponds with 28. Okay, so those would be my three ratios. Now, in order to solve for x, what I would do is, let me zoom this in a little bit so it's a little bit easier for the C if you're playing at home. You would pick, if you're solving for x, you would pick the ratio 18 over 4x minus 4, and then you would set it equal to one of these other two ratios, either one. Okay, I'm going to pick 9 over 12 for the sole reason that they're smaller numbers. And then we cross multiply to solve out for x. Okay, so 9, remember now when you multiply 9, you have to multiply by the quantity 4x minus 4. So that's 36x minus 36. That's going to be equal to 18 times 12. Don't be impressed with this, Chris Dolan. I'm doing it off screen. It's 216. Now I solve. Add 36 to both sides. That means 36x is equal to 252. Divide by 36. X is equal to 252 divided by 36, 7. X is equal to 7 for number 13. Okay. Number 14, same idea. Okay, so now notice in number 14, we have this side is 10x minus 10. It's going to correspond with the 2x side. So there's one of my ratios. I'm doing big triangle over small triangle. And then the 10 side corresponds with the 4 side. Solve for x, I set them equal, and I cross multiply. Okay, same idea here. So 2x times 10 is 20x. 4 times 10x minus 10 is 40x minus 40. Remember, you have to distribute the 4. And then I'm going to solve. So I'm going to take away 40x's from each side. That would cancel those out. 20x minus 40x is negative 20x. That would be equal to negative 40. I divide both sides by negative 20. And so x would be equal to 2. Okay? There we go. So that would be how you do that assignment.